316. So it just says at the bottom, what is a logarithm? A logarithm with base a just means if the log is base a here, a to what power is x? So it's just rewriting it the way that I just rewrote it. The one that I always think of for some reason, I do the log base 2 of 8 equals 3 because 2 cubed equals 8. So just being able to go back and forth between exponential and log helps me with the definition of log in my own head. I kind of think of it as this circular relationship. The base is 2, you raise it to the third power, and you get the number inside. So 2 cubed is 8. So I rewrite this for myself when I'm trying to do logs because this log doesn't make as much sense to me as writing it as an exponential function. So maybe if you write those two equivalent expressions down at the top of a paper, it would help you to go between them. And it just says that x can never equal 0, a can never equal 1, and a cannot equal 0. So your base of your function, it wouldn't make sense if it was 1, because 1 to any power is always 1. X can't be 0. That's going to come into play when we graph logs. There's going to be an asymptote there, kind of like there's an asymptote at y equals 0 for the exponential functions. So just logarithmic functions are the inverse of exponential functions and vice versa. So a logarithm is just an exponent. So it's just another way to represent that exponential relationship. So then just there's another example. Log base 2 of 16, or log base 2 16 equals 4 just means 2 to the fourth power equals 16. Whoops. So the reason we need logs, the reason we need these inverses of exponential functions is because you just spent some time in your exponent lessons, basically, figuring out the powers of 2 or the powers of 3 and what they are. Now I want to evaluate something like 2 to what power will give me like 12. 12 is not a power of 2. So I know that it's between 2 cubed, which is 8, and 2 to the fourth, which is 16. So it's got to be 3 point something, but I have no way right now to guess what that exponent is. Is it 2 to the 3.8 or 2 to the 3.9? So having inverse functions, we're going to use it to solve equations like this. And then instead of having to guess and check on our accounts about interest or population growth or radioactive decay, it's going to give us an exact method to get the answer, basically. So you need inverse functions to solve equations with exponents. So on the back page, it's just having you reinforce changing from log to exponential form again. So, for example, in number 1, it says rewrite in exponential form and evaluate. That just means, say, 2 to what power equals 64. So you're just evaluating it like you just did on the front page. Does anyone know 2 to what power is 64? Right, because 2 to the fifth is 32. So rewrite each of those in exponential form, and then you're going to rewrite 5, 6, and 7 in log form. And what that means is you're going to take the base of your exponent, so like log base 4, 16 goes inside the log, and 2 goes outside the log. So I'm just rewriting the exponential expression as a log expression instead. So if you could take a minute and try 1 through 7 to just practice going between the two forms a little bit more, and we'll put up the answers in just a minute. Answers, so they're also in the video here. So number 2, you're asking yourself 3 to what power is 27? So the answer is 3 to that one. We did that one kind of on the front page or the warm-up. This is asking you 10 to what power is 1 over 10,000. So if there's 1, 2, 3, there's 4 zeros. Right? 1, 2, 3, 4 zeros. It must be the negative fourth power because it's flipping it over, right? 10 cubed is 1,000. So 10 to the fourth would be 10,000. And then, oh man, I never unpaused this video. So number 8 through 11 has you practicing evaluating those on the calculator. So you're going to type in the log of 8 equals, so what do we get when we type the log of 8? 0.90, right? If I do 2 decimal places, everyone get log of 8 is 0.90. 0.90. So you're going to try 9, 10, and 11 using your calculator, because all of these you can't do in your head. So try them for just a minute. We'll see if you probably also have that button on your phone. If you turn your scientific calculator sideways, you probably have a log and a natural log button. So one key that your phone calculator might not have is a change of base key. So when you look at number 12, if you have to do the log base 4 of 8 on your regular calculators that you have at home without a graphing calculator, you'll have to type in the log of 8 and divide by the log of 4. So that's called the change of base formula. Take the log of that big inside number and divide by the log of the base. So try typing that in on your calculator. The log of 8 divided by the log of 4. Put your parentheses in there. What did you get when you do the log of 8 divided by the log of 4? All right, 1.5. So I want to show you another special key on your graphing calculators. If you go under the math key, under the word alpha, and you scroll all the way down to choice A, see if you scroll all the way down, 4, 5, 6, 7, 8, 9, 0, A, says log base. That log base key allows you to pick your base and pick your inside number. So if I wanted the log base 4 of 8, I could just use that log base key and it would also give me 1.5. So if you don't have a fancy calculator, you have to use that change of base formula, the log base 10 of 8 divided by the log base 10 of 4, common log. But if you've got the fancy graphing calculator, it's under, you might want to write down, it's under math, choice A, log base. But if you forget where it is, it's not a big deal. You could just take the log of that inside number and divide by the log of the base. Can you try it maybe both ways for number 13? See if you can evaluate 13 now. And then we're going to talk about inverse, because remember I said on your quiz I wasn't going to put inverses on your quiz. So here's another look at inverses again. So there will be inverses on your log quiz later next week. But so an inverse, we learned that an inverse algebraically, you just switch x and y. So if I want to find the inverse of this function, first step is to switch x and y. So x equals 6 to the y power. That's not a function, right? A function is y equals something. So how am I going to get y out of the exponent? I'm going to use the inverse function, which is a log. So what I'm going to do is I'm going to rewrite this in a log expression. So the base is going to be 6, log base 6 of x equals y, right? Because isn't 6 to the y power equal to x? So aren't those equivalent expressions? Why is this one better? The only reason this one is better is because it's a y equals equation. Right? So if I wanted to graph this, it would be y equals log base 6 of x is how I would type it into my calculator. This, x equals 6 to the y, that's not a function. So if you start in exponential world, you're going to end in log world and vice versa. Just like you start with addition, you're going to end up with subtraction. Start with multiplication, you're going to end with division. So let's try example 15 the same way. So I switch x and y. So x equals 4 to the y power plus 1. I'm almost ready to switch it into log form. I have to get 4 to the y by itself before I switch it into log form. How am I going to get rid of this plus 1 over here? Just subtract 1 to the other side. So that's another inverse operation, right? So I have x minus 1 equals 4 to the y power. It's a lot of algebra skills. Now I'm going to change this into a log equivalent expression. So my base is going to be 4 because that's the base of the exponent. X minus 1 is going to be pulled inside the log, and I get my y equals on the outside, right? 4 raised to the y power equals x minus 1. So it's making it a little bit more abstract. You can't check your answer like you did on the front page with like an exponential, 2 cubed is 8. But all you're doing is using the switching of forms. So could you try 16 for a minute on your own? Try to find the inverse. My first step is to switch x and y. My next step is to rewrite it as a log expression. So my base is 2. X gets pulled inside the log, which frees up that y minus 3. But y is still not by itself. So my last step was to add 3 to the other side. So when I rewrote it as a function. Y equals the log base 2 of x, and then plus 3 on the outside. So this is hard. It's the first time you've seen it. Inverses are challenging. To me, this is the most challenging. I think it's more challenging than the applications that you're going to do. So it's not going to be highly assessed on your unit test, but it is important to know, exponents and logs. So the last thing I wanted to look at is just 17 through 19, because this is now finding the inverse of a log. So guess what? When you start with a log, this time you're going to end in exponential world. So you're going to start by switching x and y, just like I did before. So x equals the natural log of y plus 3. I need a base to work with. What base is missing from being written there? What's the base of the natural log that we said on the previous page? Right, the base of the natural log is e. So I'm just going to throw e into this expression right there for the base. So if I start in log world, I need to end in exponential form. So the base of my log becomes the base of my exponential expression. So e to the x power equals y plus 3. So the y is currently trapped inside the log. So when you switch form, the x gets trapped inside the exponent, which frees up that y value. So my final function would be y equals e to the x, and then I'd still have to subtract the 3 to the other side. Yeah? So number 18, x equals log of y minus 5. So your first step is to switch x and y. I need a base in this problem. So if it's a regular old log, what's the base have to be? 10. So you're going to write the 10 in there. Oh, and before I switch, I've got to move this 5 to the other side, right? So I'd have x plus 5 over here equals the log base 10 of y. When you start in log form, you need to end in exponential form. So my function, if the base is 10, my new base is going to be 10 raised to the x plus 5 power equals y. So I've changed form, and now I have a y equals function. So could you try 19 for just a minute on your own for this last function? And when you're finished, you're going to look up and see if you got the right answer, and hopefully you did. And that is where we're going to end for today, is inverses.